Hello friends, so let's talk about a recurrent neural network. So before learn about a recurrent neural network, let's go back and see what all the things what we have learned. We have learned the two neural networks, right? One is the deep neural network and another one is the convolutional neural network. So in both the neural network, convolutional neural network and a DNN, we have a static input and my model would get trained through the neural network framework, right? However, if there one input would not be dependent on the another input. In case if the scenario comes that we have a series of an input and all the inputs are dependent on each other, and then we need to predict the output. In that scenario, my deep neural network and convolutional neural network will not work. So let's see how the recurrent neural network would be different from the feed neural network and the other networks, right? So let's go forward. So why the RNN would be used? So RNN are used for a time series analysis, right? So when you need to make a prediction based on the previous data, not only the current data, they make a use of a sequential information. So let's take an example, right? So let's take an example of a stock price prediction. So you can't just predict the price of a current month by just looking at a one input, right? So you cannot predict the uh, uh, price of an stock price just by looking the previous day's stock price. So you need to see the trend, you need to see the seasonality. There might be the scenario that at a time of Christmas or in a festival season my stock price goes up, or at a time of some recessions my stock price go down. So we need to see the seasonality as well as a trend, right? To make a new prediction, so it depends upon the series of previous inputs, and then only we can predict it. Let's take another example of a text generation. You can't just predict the next word based on the previous word. So for example, like she spoke to her husband. If you want to predict a her, you cannot predict it by just seeing the previous input too, right? So when your text generation algorithm would predict one word by word, and it has to predict her, so uh, the algorithm has to look to what is a contextual understanding of this particular text. So when she comes, that's why it comes to the her. So you need to look at a whole sentence to understand its context, right? So in another way you can say that you need to think about RNN is that they have a memory which captures the information about what has been calculated so far, right? So it is not, it doesn't depend upon the previous input, but it all depends on the all the previous input which is stored into a memory. So that's why the RNN would be used when we need to store all the previous memory, and the prediction would be depend upon all the previous seeing the trend, seasonality, and the contextual information from all the previous inputs, right? So how my RNN works, right? So RNN is what RNN does. It RNN is have a several copies of a same neural network that are aligned together, and each one passes its output to the next one, right? So just taking an example over here. So this is my one neural network, right? So this is an input, this is my hidden layer, and this is an output. And x1 and x2 and x3 are the my different inputs. Suppose we have text, right? In the text we have different words. So how are you doing? So x1 is a how, x2 is a r, and x1 is a y. So what it does, it is the same network which is copied three times. So each neural network is called as a timestamp. So if the sequence we care is a sentence of a three words, we would have a three copy of a network, one time for each word, right? So each copy is called as a timestamp because it receives a different input at a different time. So when we'll pass the one word at x1, it generates an output, it does certain calculation at a hidden layer, and then generates an output y1. And then this h1 hidden layer, which we call as a memory, would pass to the second input. And when the second input pass, this s2 would be calculated with an h1, and then the generated an output of y2. right? And then again this hidden h2 would be passed to the next input. So subsequently all the input like s2 would be dependent on h1, s3 dependent on an s2, and s2 dependent on an h1. So at the last, the h4, when you predict the y4, this y4 would be having all the memory which we are having it for x1, x2, and x3. So it has all the contextual information of all the previous layer, right? And then based on that, plus the based on the new input, it would predict my y4. So if you'll see the calculation over here, so this is again calculated the weighted average, that is and one more thing over here, that because as I have already said that RNN is a several copy of a same neural network. So this is the same network. It is just a representation purpose. I have shown it 5 times. So the first time I have an inputted over here. So each neural network is a timestamp. So it's a sequence we care about over 3 sentences. So each copy is called as a timestamp because it receives a different input at a different time. So all the weights which is associated with it is same in all the 4 networks, right? So if you see over here, WH is over here for X1, it is WX. The weights are same for all the 4 neural networks, right? And the activation function we have passed over 10H. So the hidden formula would be the weighted average, and then to the activation function on the weighted average, right? So this is an H1, and this H1 would be passed to the H2. So if you see the formula for an H2 is WH H1. So H1 would be dependent, H2 would be dependent on H1. Similarly, this H4, we have an input received from the H3, and this H3 has an input dependent on an H2. So that is how my neural network works, right? So this is how my recurrent neural network works. So now let's see how the visual representation of RNN works. So if you see it over here, this is a feed neural network. This is an input layer, this is a hidden layer, and this is an output layer. We just need to flip it and make it in such a way that this is an input layer, this has become input layer, hidden layer, and this is an output layer. It is just a representation, visual representation, how we are representing a recurrent neural network. Now we need to pack it up all this neural network so that all this multidimensional neuron we can see into a single dimension, right? So we have just packed it up into one, and it can be shown. And if you have seen online and all the course material, you would have find this would be the neural representation. So this is not a single neuron, it consists of a several neuron, right? So it represents a multi-dimensional neuron as a one neuron. If you'll see a recurrent neural network, the same network means it a multi-dimensional neuron of one neuron. The same network would be copied 5 times, and the input of a one timestamp would be passed to the input of a next timestamp. So, right? So the copy of a same network for a number of a timestamp. So if you expand this image into this, you can see that the first timestamp, the input is this. It is a multi-dimensional neuron, and when it passes to the hidden neuron, and the output would be generated, and the memory of this would be passed to the second timestamp, and then the again input would be passed from here, and then taking taking a memory from the previous timestamp, it generates an output. So that's why it is called as a recurrent neural network, right? So hope this session would be helpful for you. For in next session, we will understand more about an RNN, how RNN works, how the backward-propagation of an RNN works, and what are the advantage and the disadvantage of an RNN. So thank you guys.